Hi AB Calculus students. This is 2011, question number 4. The topic is still FTC, Fundamental Theorem of Calculus, and this is still one of your topics coming up on your quiz later this week. Alright, you'll notice here they gave us the graph. They said this is the graph of f, and then they gave us a strange-ish piece of information. They said g of x is equal to 2x plus this. Okay, so let's go ahead and jump into part A. Now to deal with part A, there's 3 parts to part A. So part A has 3 parts. The first part says find g of -3. So let's start with the first part. If I want to know what is g of -3, every x is a -3. So a -3 here and a -3 here. So -3 goes here, -3 goes here. Okay, now I just have to work this out. So my answer here, I don't even have to simplify this. If you want to change this to -6, that's fine. I'm not changing it. And I need to add the area from 0 to -3. So this is the area underneath the graph of f. This is the graph of f. So we need the area underneath the graph of f from 0 to -3. This very well could be on your AP exam, something just like this. Now let's go ahead and look at the area. From 0 to -3, it's simply this quarter circle. So we know the area of a circle is pi r squared, but this is a quarter circle, so it's 1/4 pi r squared. And the radius of this is 1, 2, 3. So we just throw a 3 in there and we're done. The area from 0 to negative... Oh no! Bad Mr. Pygott. While this is almost correct, there's a small problem. What do you notice about those two? Do you see it? They're in the wrong order. You have to make sure these are in the right order, and they're not. If they're not in the right order, you have to flip them. So we're going to flip them. I'm going to put the 0 up here and the -3 down there. And if I flip them, the price to pay is a minus in front. And now we're done. G of -3 is this minus this. There's nothing to simplify. Now that's only the beginning of part A. But let's go ahead and erase that. So that's the beginning of part A. The next part of part A says first find g prime x. Well, g prime x, we have to start here. To take the derivative, I have to take the derivative. The derivative of 2x is 2. And now over here I have to take the derivative. But remember what happens when the derivative runs into the antiderivative. The derivative destroys the antiderivative and x jumps in. So derivative destroys the antiderivative, x jumps in, and this is what we get. So g prime x, I took the derivative, is 2 plus f of x. Okay. Now once we have this, they ask us to do one more thing. They say find g prime -3. So to find g prime -3, the x is a -3. So it's 2 plus, and then I put a 3 there, f of 3. Now, folks, this looks like it's going to be really difficult. Oh my word, what's f of 3? Help me! F of 3. This is the graph of f. F of 3 is just this ordered pair here. And if you look at the information they give you, they even tell you, hey, this is the ordered pair 3, -3. So that is -3. If you have the graph of f, which we do, and we want to know f of 3, it's just simply the ordered pair. And there you go, that's your answer. Could you simplify this to -1? Yes, but you don't have to. I'm just going to stop right there. That's my answer. Great. So that's part A. Part A is over. Part A is worth 3 points. All right, now let's look at part B. Part B says, determine the x-coordinate on the point when G has an absolute maximum. This isn't the graph of G, right? This is the graph of F. We want to know, when does G have an absolute maximum? Now, who can win the absolute maximum in words, endpoints or critical points? But before we do this, let's go ahead and try to make a sign chart of G prime x. Absolute maxes and mins can occur at endpoints. My endpoints here are -4 and 3. And critical points. And critical points, this is important, critical points are where the derivative equal 0. So when does G prime x equal 0? So we set G prime x equal to 0, and then something interesting happens. I can move this 2 to the other side, and I'll get, when does G prime x equal 0? When f of x is -2. Now, let's look at the graph of f of x. This is the graph of f of x. When does f of x equal -2? So I'm just going to go ahead and draw a little dotted line right there. Now, if you're paying attention to slope, you will notice that this graph goes down 1, 2, 3, 4, 5, 6, and over 2. Now, over 3. Sorry, if it goes down 6 and over 3, it means it goes down 2 and over 1. So it goes down 2 and over 1. So that's at 1, 1. It goes down 2 and over 1. So that's at 2, 1. And this is 3, 1. So this is when x is 2. When x is 2, it's here. When x is 3, it's here. This is perfectly in between when x is 2.5. So when does G prime x equal 0? When f of x is -2, which happens at 2.5. And this is a crazy question. Okay, now, it's almost like our sign analysis chart has kind of been shifted. Instead of saying, when is it above or below 0, it's basically, when is it above or below this 2.5. Well, it's above 2.5 over here, and it's below over here. It's above and then below. But there's another way of thinking about it. Remember what G prime x is. G prime x is 2 plus f of x. Okay? Look at all these f of x's over here. They're all above -2. So all the heights are above -2. So if you put anything above -2, 2 plus anything bigger than -2 will give you a positive answer. What if you take anything on this side? My numbers here are below -2. So like -2.2, -2.3, the heights are below -2. And if you take anything below -2, like -3, 2 plus anything below -2, like -2.1, -2.2, it's going to give you a negative value. Now, why is this important? I said the absolute max or mins can be won by endpoints or critical points where the derivative equals 0. So these are my only candidates. However, they all can't win the absolute max award. Look at what this tells me about G prime x. Positive negative tells me G of x was increasing and then decreasing. So it turns out that these two right here could have won absolute min awards. This is the only one who could have won an absolute max award. So we would say G has an absolute max at x equals 2.5, or you could say 5 over 2, because G prime x was positive from -4 to 2.5. Or, of course, remember, when I say this, if you want to look all fancy, you could do this. From here and negative from 2.5 to 3. Or again, if you want to be fancy, instead of saying this, you could say when x is between 2.5 and 3. Anyways, again, they know what this means. This means it was increasing and then decreasing, therefore that relative maximum is actually the absolute max. And that's part B. All right. Part C. They want to know, when does g have points of inflection? Now, points of inflection, you would make a sign chart of the second derivative. And we don't have the second derivative yet, so let's take the derivative. Here we get g double prime x is equal to f prime x. Okay, and this is key. Notice the 2 here went away. So much nicer not having this 2x or this 2 here. It's gone finally. If I want to sign analysis chart of g double prime x, it's the same as f prime x. So sometimes we'll write stuff like or f prime x. So g double prime x is f prime x. So if I make a sign chart of f prime x, that's a sign chart of g double prime x. So if this is the graph of f, how do I make a sign chart of f prime x? So again, this is f. I want a sign chart of f prime x because f prime x is this. Well, what features do I look at? To go from f to f prime, I look at slopes. What do you notice about the slopes? Positive slopes until you get to 0, and then negative slopes until you get to 3. So let's go look at our sign chart now. G double prime x, or f prime x, was positive and then negative, meaning g was concave up followed by concave down. That's your only point of inflection. So, point of inflection at x equals 0, because, and if you labeled this sign chart, g double prime x, it doesn't count unless you said somewhere that g double prime x is f prime. That's important. So, or you could have said, just call this f prime, because g double prime x changes signs. And as long as you have the work, a sign chart of g double prime x, they can see that what you mean by changes signs. If you didn't write that, the only other thing you could say is something like the graph of f went from increasing to decreasing. Points of inflection are where some graph, whatever. We're good. In this question, f slopes are f prime, which is g double prime. But we're not going to go any further. I think I explained that one enough. All right, let's go to part D. Part D is a very important question. They ask you for the average rate of change of f. And the reason that it's important, the average rate of change of f, oops, didn't have enough space there. Average rate of change of f from -4 to 3. Okay. Average rate of change is on your AP exam. Now, if it had said average value of a function, nope. Average rate of change, yes. Average rate of change is simply this. Average rate of change is simply slope. Rate of change means the derivative, average. An average rate of change is you're averaging the derivative. You're averaging the slope of the tangent line by finding the slope through 2 points. So this is just y2 minus y1 over x2 minus x1. Average rate of change is old school slope. So in order to find this, we simply need to know what is f of -4 and what is f of 3. So let's start with f of -4. F of -4, we can just look. F of -4, f is -1. If it helps you, you can write it as the ordered pair -4, -1, and then f of 3. F of 3 is down here at -3. Or if you like, you can write this. So, average rate of change, subtract the y's on top. So -3 minus -1, or of course you could just make that a plus. So -3 minus -1, and then on the bottom 3 minus -4, which I'm just going to make it minus a negative, make it a plus. There you go. You do not need to simplify it. If you do simplify it, you get -2 over 7. Okay, so that's the first part. That's your average rate of change. The second part says, explain why this statement does not contradict the mean value theorem. Well, what does the mean value theorem state? it states that f prime c would have to equal this. In other words, remember mean value theorem, if we can find the slope through the endpoints, we're guaranteed somewhere between a and b, there will be some c where the slope is the same. So what did we find when we found the slope of negative 2 over 7? We found the slope of this. If you were to count, this goes down to an over 7. The mean value theorem says, hey, there should be some point where you get the same slope. There's never a slope of, these are all positive slopes, and these are all negative slopes, but these slopes are negative 2, not negative 2 over 7. So the mean value theorem isn't working here. But the mean value theorem has to work. So they're saying, well, why doesn't this contradict the mean value theorem? So the mean value theorem only works if a function is continuous and differentiable. So we could simply say the MVT does not apply because, and when we say differentiable, we mean smooth, no sharp turns, because f is not differentiable at, where is it not differentiable? When x is 0. That's where your sharp turn is. So because there's a sharp turn, or you could even say, because there's a sharp turn, the mean value theorem does not apply. All right, anyways, that's part D. Very important. Average rate of change is this part. The average rate of change is this part of the formula, and I apologize, I never changed this whole thing to D. Sorry. Anyways, hope you enjoyed the video. Bye.